Okay, so let's start looking at the atom. So what I have here is a picture, an image using a quantum microscope of what the hydrogen atom looks like. By no means am I going to be able to draw what these things actually look like. I'm actually going to go back to the old-fashioned Bohr model. When we talk about the position of electrons and protons and neutrons, they're really three-dimensional, so these atoms are going to take three-dimensional shape instead of two-dimensional shape. But you guys have already seen my drawings. You know it's going to go through and stick with two-dimensional pictures. So what is an atom? Okay, so in general, what is an atom? So this is the smallest unique, that's going to be the key part there, particle of matter. Okay, so the simplest form of matter that we can have. And a lot of times we're going to refer to, instead of atoms, an element. Spell that correctly. So when we talk about like the hydrogen element, the periodic table has elements. So what are we referring to there? So for an element, so by an element, we're going to talk about it being pure. So it's all hydrogens, or it's all carbons, or it's all oxygens. So you're not going to have a mixture and suppose more a molecule or a compound. So you'll see us talk about, not into great detail, but I want to show you these words just to kind of help you be familiar with them. A molecule, oops, sorry about that. Two or more atoms chemically joined, sodium, or sorry, salt, sodium chloride. So this is salt. So salt is a molecule. It's not an element. It's not, they have two different atoms here. So you got a molecule. Compound, oops. And these definitions are going to be kind of confusing. I'm going to go through and give you some videos to help you with the definitions. And molecule and compound sound very similar. Two or more atoms chemically joined, or two or more atoms of different elements chemically joined. I know even some places will put sodium chloride down here. I am not going to test you on molecule or compound. I am going to focus on atom and element as far as what I test you on. But I want you to be familiar with the vocabulary as we're going through. And then a mixture. So two or more elements or compounds, not chemically joined. Like check party mix. You got peanuts, you got pretzels, you got the cereal, something like that. So they're not mixing together. You can actually pull the individual particles out. So when you talk about mixture, you can pull those individual elements out. A cake would be a compound because it's mixed chemically and you have something new. A can of mixed nuts is a mixture because you have different types of nuts in there. So I just want you to see the vocabulary again. We're going to focus on atoms and elements, especially from the beginning. We may, depending on time for the semester, we may move our way up, but we're going to focus on the atoms and elements. So what makes up the atom? So the parts of the atom: protons, neutrons, and electrons. Protons, neutrons, and electrons are in the nucleus. And these electrons are flowing around the nucleus. we know that they're actually free and they'll just be moving around, and whenever they need to, they'll jump into a shell closest to a nucleus. But for our sake, for drawing them, we'll take a nucleus and we'll put the protons and the neutrons inside, and we'll have the electrons going around. So I want to show you this table. So I will be honest, I do not put these superscripts on the protons and neutrons. I will put it on the electron because we're going to talk about positrons later on. So electron, we have protons, neutrons, electrons. So if we look at these, the charge of a proton is +1. Neutrons are neutral, they have no charge, but they're very important. And in fact, in chemistry, what's crazy is in chemistry is they don't really talk about the neutron. So when we get into the nuclear medicine, that's where the physics really comes in, is the impact of the neutron to these reactions and to decays, fusion and fission and so forth. We have an electron that has a charge of -1. And here's the big difference. So let me jump to this table right here. The mass difference. Now this is in grams. So these things are super, super, super small. If you look at this, the protons and the neutrons have roughly the same mass, and the electrons are on the order of 10,000 times less massive. And a lot of times in chemistry, they ignore this mass, but the mass is going to be actually super important. Now in chemistry, they like to use the atomic mass unit. And that's equal to U. So the proton, a lot of times they'll say is 1U. They'll round that up to 1. A neutron will have a mass of 1U. And then this is going to be approximately 0 because it's much smaller than 1. This is kind of a shorthand way. This atomic mass unit is a shorthand way of writing the masses, so you don't have to write these big numbers out. And again, the locations of the protons, neutrons, electrons. Don't memorize these. If I give you a problem where you need a mass, especially in the next unit we're doing nuclear medicine, I'll give you those masses. Or you'll have the table available for you as well. So one or the way or the other. But you need to understand that the protons and neutrons, even though they have different charges, they have pretty much the same mass. The electrons have way different mass, but the same charge as a proton. And so what we're going to do next is we're going to go and start looking at the periodic table and how to read the periodic table, what does the periodic table mean, and how to transcribe it. And one of the reasons we're going to focus so much on the periodic table is it really tells you a lot about the element that we're dealing with, and then how they can interact with other elements, especially and when we get into the nuclear, where we're doing nuclear fusion and we're doing fission. And so how something can break down or it can add up, one or the other. So we want to spend some time looking at the periodic table in this module. Again, we're really going to look at the basics of chemistry, but we really want to focus on the periodic table. So in reality, you could call this module the module of periodic tables, but we're going to kind of introduce chemistry by focusing on that periodic table.